The main type of low-pressure system or depression that affects the weather in temperate mid-latitudes are those that form in association with fronts. These are called frontal depressions. However, there are several other types of lows or depression that we shall consider throughout this lesson. Orographic or lee lows occasionally form, as the name suggests, to the lee of high ground. When air meets a significant barrier in the form of a range of hills or mountains, its options are to go around or over the top of the high ground. The resultant airflow depends on the stability of the atmosphere on that day and the strength of the airflow hitting the barrier. Most orographic depressions form in stable conditions when there is a resistance to the movement of air vertically. When air meets a range of hills, there is a tendency for it to build up on the windward side of the high ground, with a corresponding slight depletion of air on the leeward side. This reduces the amount of air on the lee side, therefore reducing the surface pressure. This situation results in lee troughing, or, on occasions, an orographic depression or lee low. The isobaric patterns look like this. Orographic effects, such as lee troughing or lee lows, can form rapidly. They may also last a short period of time, say an hour or two, or can, on occasions, last for several days, varying only in their intensity. They tend to be stationary, seldom moving from the location where they were created. The main hazard associated with orographic lows are the strong or unpredictable winds that can accompany them. As you can see here in this example of lee troughing, the spacing of the isobars in this area is small, and hence the low-level winds will be very strong. With a lee-low example, the low-level winds are very variable across a relatively short distance, an important effect for the pilot. There are other effects of air being forced over high ground. When the atmosphere is stable, perhaps because of an inversion, we get the most marked effects over high ground. If you remember, stable conditions restrict the vertical movement of air. Therefore, the air will be forced up the windward side, but flow back down the leeward side. The Föhn effect is usually the result, with some warming and drying out of air mass as it descends on the leeward side of the high ground. We can also find very stable conditions ahead of a cold front. In this situation, there may be masses of low cloud forming on the windward side and just over the top of the high ground, with relatively clear conditions on the lee side as the air descends. The orographic low forms here, and severe convection may result on the lee side, caused by convergence of the low-level winds and strong heating by the sun in the absence of other cloud. If the atmosphere is unstable, orographic lows rarely form, but there may still be some lee troughing effects. In this case, the instability can be released by uplift over the high ground and the heating effects of the sun. The vigorous convection takes place over the high ground, perhaps even leading to cumulonimbus development, with the associated hazards of hail, turbulence, icing, and thunderstorms. Examples of hill or mountain ranges that often cause lee effects are the Pennines in the UK, the Alps, and the Rockies. The best cases are when hills or mountains lie at right angles to the prevailing wind flow. So be careful when planning your flight to check the wind directions over any high ground, and if so, anticipate potential turbulence hazards. In the lesson on pressure systems, we looked at the basic concept of small-scale thermal lows or depressions. Examples of these are heat lows, which form over land in the day during the summer months, such as those we often see over the Iberian Peninsula. In winter, over bodies of water, such as the Caspian Sea and the Great Lakes of North America, we sometimes see the same effect. Here, though, the low pressure is created because in winter these water surfaces are warmer than the cooler surrounding land. In clear cold conditions, low pressure will sometimes form over the sea or lake, with the effect being particularly noticeable at night when the surrounding land is at its coldest. It is the difference in temperature between the water and land that causes the formation of these types of heat lows. The weather that's associated with these thermal lows can vary greatly, but the increased warming in the depression and the low-level convergence of wind can result in very active convection. Particularly in summer over land, cumulonimbus clouds and thunderstorms sometimes develop with heavy precipitation, possibly even hail, turbulence, icing, wind shear, and poor visibility, all causing significant hazards to aviation. Another type of depression that occasionally develops is the polar low. Polar lows form in Arctic air masses when cold air moves towards the equator across warmer seas. They are relatively small in scale, both vertically and horizontally, but their effects can be very significant. With cumulonimbus activity, heavy snow showers, and strong low-level winds are possible. A typical place to find this type of depression is off the coast of Norway. They form to the northwest of Scandinavia and then move south as they get caught up with the flow. If they hit land, which is generally much colder than the sea at these latitudes, especially in winter, then they tend to lose their strength and fade away. Over the large continents in summer, we can find large-scale thermal lows developing. Because of their scale, they dominate the weather over a significant area. The best example of this type of low is the Asian monsoon low, which forms in summer off the Tibetan Plateau. Another large-scale feature, which is driven thermally, is the equatorial low-pressure belt, or intertropical convergence zone, ITCZ as it's also called. This effectively is a line of convective-type weather which circles the Earth, marking the thermal equator. The position of this moves throughout the year, oscillating north and south with the overhead sun.